Okay, so just to maybe make things a little bit more difficult, what we can do is look at finding the zeros of a rational function. So a rational function is just two polynomial divided by another polynomial like we have here. So yeah, to find the zeros, for the most part, it's just the zeros along the top. But what we can do though is kind of get started by doing the approach that you might want to naturally do anytime you see a rational or these polynomials is get factoring. So that's what we're going to do. We're going to start by factoring everything. The bottom is nice and easy. That's a difference of squares. So that should just be x plus 3, x minus 3, which is nice. For the top, we're going to have to use the techniques learned in this section. So that's not how you spell techniques. So I will start by listing out my potential rational zeros. So that will be plus minus, so the factors of the constant, which are 1 and 3, divided by the factors of the lead coefficient, 1, 2, 4, and 8. It'll be a decent list, but not too bad. So I'll have 1 and 3, a half and 3 halves, a quarter, 3 quarters, an eighth, and 3/8. And plug them in till I find something. So let's just denote, let's call the top, why don't I call it T of x for top? Just so I've got some kind of notation to use here. So T of 1 is 8 minus 22. It looks too negative. Yeah. And T of negative 1 will be negative 8 minus 22. Probably going to be too negative again. Plus 7 plus 3. Yeah. Too negative. Let's try T of 3. What is that? Ugh, 8 times 27. I want to say 216. Yes. 216 minus 22 times 9. I'm hurting myself now. I think that's 198. 7 times 3 minus 21 and plus 3. And so what do we get? The positives are 219. And the negatives are also negative 219. So yeah, we get our 0. So that is good. I know that x minus 3 is a factor. That's interesting if you notice what I did for the bottom there. So I'm going to factor it out. I'll use synthetic since it sets up nicely for this. 8, negative 22, negative 7, and 3. Make it ugly. Let's see. 8. No, it's not too bad. 24. Add them together to get 2. 6. Add them together to get negative 1. Times 3 is negative 3. And there's that 0 that I absolutely need. And so my T of x is 8x squared plus 2x minus 1 and times my x minus 3. And I think I could probably, I think I can factor the 8x squared plus 2x minus 1. You kind of just use a reverse rule if it had been x squared plus 2x minus 8. What should I get here? It should be 4x minus 1 and 2x plus 1, I believe works. Yeah, x minus 3. And so for q of x, what we actually get is, let me write out this whole thing. 4x minus 1, 2x plus 1, and x minus 3 over x plus 3, x minus 3. And so what you should see here is that there's actually a little bit of cancellation. In fact, q of x, we're going to cancel those. We do want to keep track of the fact that if we do cancel that, we should note that x can't be 3. So this function q is not defined at 3, and I do lose that piece of information if I do that cancellation. So q of x is going to be 4x minus 1 times 2x plus 1 over x minus 3, x plus 3. And I'll note that x can't be negative 3. Now what I'm looking for is the zeros. So if I were to set that thing to 0, what I could sort of do is multiply the bottom up to the top, but it just gets wiped out by the 0. So the zeros actually end up just being the top zeros, but the simplified top zeros. So we do need to omit anything that would cancel. So it's just those simplified top zeros. So I should get a quarter from the first one and negative 1/2. And yeah, those would be my zeros. Usually you won't have any sort of weird cancellation like that, but it's something to look out for. So that's why I included it in this example. Yeah, so for the most part, the rational zeros are just zeros across the top. The zeros along the bottom have their own significance, which will get talked about later on in, I don't remember which section, but later on in this chapter.